Hello everyone and welcome to my channel. This is the A+ Tutor. Today we're going over factoring quadratic functions. Quadratic functions are functions of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. We factor quadratic functions in order to find the zeros of our function. Here's how we factor these functions. First, we'll find the absolute value of a times c. Then, we'll find all the factors of what that is, of what a times c is. For example, if a times c were 6, all the factors of 6 are 1 and 6, and then 2 and 3. Then, we'll select the factors of a times c that will combine to give us b. So for example, if we had a times c is 6 and our b is 5, we would select 2 and 3 because when we add those together, we get 5. Additionally, we'll need to confirm the sign of each of our factors to make sure that we have the correct b term. Finally, we'll factor. When the absolute value of a is equal to 1, then we'll simply rewrite our quadratic function as x plus the first factor times x plus the second factor. When the absolute value of a is greater than 1, then we will factor by grouping, and I'll dive more into that in an example. Let's look at some examples. Let's take f of x equals x squared minus 7x minus 18. A equals 1, b equals negative 7, and c equals negative 18. First, we'll find the absolute value of a times c. So this is the absolute value of 1 times negative 18, which is the absolute value of negative 18, which is equal to 18. Second, we'll find the factors of 18. So the factors of 18 are 1 and 18, 1 times 18 gives us 18, 2 and 9, and 3 and 6. Next, we'll select the factors that combine to give us b. Our b is equal to negative 7. So the factors that will give us negative 7 are going to be 2 and 9, where we have a positive 2 and a negative 9. So this is where we have to check our signs. We need to make sure that we get a negative 7. That's only by having a positive 2 and negative 9. Lastly, we'll rewrite this as x plus the first factor times x plus the second factor. So we get f of x equals x plus 2 times x minus 9. To check we have the right factors, we can FOIL this out. So by multiplying first, outside, inside, and last, we get x squared minus 9x plus 2x minus 18, which simplifies to x squared minus 7x minus 18, which is what we started with, so we are correct. Let's take another example. F of x equals x squared minus 3x plus 7. A equals 1, b equals negative 3, and c equals 7. First, we'll find the absolute value of a times c. So this is the absolute value of 1 times 7, which is the absolute value of 7, which is just 7. Next, we'll find the factors of 7. The only factors of 7 are 1 and 7. 7 is a prime number. Next, we'll select the factors of 7 that combine to give us our b term. b is equal to negative 3. So in this case, there aren't any factors that combine to give us b, which means this function is not factorable. Let's look at another example. F of x equals x squared minus 8x plus 12. A equals 1, b is negative 8, and c is 12. So first, we'll find the absolute value of a times c. This is the absolute value of 1 times 12, which is just 12. Next, we'll find all the factors of 12. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Third, we'll select the factors of 12 that combine to give us our b term. b is negative 8, so the factors of 12 that will give us negative 8 are 2 and 6, specifically negative 2 and negative 6. We have to make both of these factors negative. Lastly, we will rewrite this as x plus our first factor times x plus our second factor. So f of x is equal to x minus 2 times x minus 6. To check to make sure we have the correct factors, we can FOIL our binomials. FOILing gives us x squared minus 6x minus 2x plus 12, which is equal to x squared minus 8x plus 12, which is what we started with, so our factors are correct. Let's look at some more examples, this time with our a term greater than 1. f of x equals 9x squared minus 5x minus 10. So our a is equal to 9, b is equal to negative 5, and c is equal to negative 10. First, we'll find the absolute value of a times c. The absolute value of our a times c is the absolute value of 9 times negative 10, which is the absolute value of negative 90, which is just 90. Next, we'll find all the factors of 90. So the factors of 90 are 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and 9 and 10. Next, we'll select the factors of 90 that combine to give us our b term. b is equal to negative 5, and none of these factors will add to give us 5. So that means this function is not factorable. Let's look at another example. We have f of x equals 5x squared minus x minus 18. So first, we'll find the absolute value of a times c. This is the absolute value of 5 times negative 18, which is equal to 90. Next, we'll find all the factors of 90. Like we just found, these are 1 and 90, 2 and 45, 3 and 30, 5, 18, 6 and 15, and 9 and 10. Next, we'll select the factors of 90 that add to give us b. Our b is negative 1, so the factors that will add to give us our b are going to be 9 and 10, specifically positive 9 and negative 10. Positive 9 minus 10 will give us negative 1. So last, we'll factor by grouping. Remember, our original function is f of x equals 5x squared minus x minus 18. Well, that minus x can be rewritten as negative 10x plus 9x. So if we write our function this way, 5x squared minus 10x plus 9x minus 18, we can factor by grouping two terms together. Let's look at the first two terms. Both of these terms have a common factor of 5x. That means we can factor out a 5x, and we're left with x minus 2. Looking at our last two terms, both of these terms have a common factor of 9. So we can factor out a 9, and we're left with x minus 2. Since the function inside our parentheses is the same in the first half of our problem and the second half, we can factor that out entirely or write that by itself, and then we can take what's left over and write that in its own set of parentheses. So that gives us f of x equals x minus 2 times 5x plus 9, and that's our final answer. Just like we did earlier, we will FOIL this out to confirm these are the correct factors. By FOILing, we get 5x squared plus 9x minus 10x minus 18, which is equal to 5x squared minus x minus 18, which is our original function, so this is correct. Let's take one last example. We have f of x equals 2x squared plus 17x plus 21. Our a is equal to 2, b is equal to 17, and c equals 21. First, we'll find the absolute value of a times c. The absolute value of a times c is the absolute value of 2 times 21, which is 42. Next, we'll find all the factors of 42. The factors of 42 are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. Third, we'll select the factors of 42 that combine to give us b. b is equal to 17. So the factors of 42 that will combine to give us b are 3 and 14, and they'll both be positive, so positive 3 and positive 14. Last, we'll factor by grouping. So we'll take our function, 2x squared plus 17x plus 21, and rewrite that 17x as 14x plus 3x. So our function becomes 2x squared plus 14x plus 3x plus 21. We'll separate this so we're dealing with two terms at a time. In our first grouping, 2x squared plus 14x, we can factor out a 2x. So we get 2x times x plus 7. In our second grouping, 3x plus 21, we can factor out a 3. So we're left with x plus 7. We have x plus 7 in each of our groupings, so we can pull that out, and then in our second factor, we'll have what's left over. So that means our answer becomes x plus 7 times 2x plus 3. Let's FOIL to check that these are the correct factors. FOILing x plus 7 times 2x plus 3 gives us 2x squared plus 3x plus 14x plus 21, which is 2x squared plus 17x plus 21, which is our original function, so we have the correct factors. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to go over. I upload new videos every Tuesday and Thursday at 1 p.m. Make sure you're subscribed so you don't miss a video. See you next time.